Good morning. Today is day 2 of factoring for terms. Okay, we're using the box method, remember? So I've already taken those 4 terms and I've put them in the boxes, and now I'm going to draw my big box so that I can break down each term. Okay, so what I mean when I say break down is I'm going to take this first term, 2x cubed, and I'm going to think about each part, the 2 and then the x cubed. So I know x cubed really means that I have x times x times x. 2, the only things that would multiply to give me 2 is 1 and 2, right? So 2 is prime. So we're just going to leave it as 2 times 1. And then we'll go on to our next box, which is 12x squared. So I know the x squared is really x times x. So I'm really going to focus on that 12 part. 2 things that would multiply to give me 12 that's not 1 would be 2 and 6, or we could have done 3 and 4, you'd get the same answer, because when you multiply, or when you factor 6, it would be 2 and 3, okay? These are prime numbers. We stop when we get to prime numbers, okay? So I have 2 times 2 times 3, and then I'll always put that times 1, because every number is multiplied by 1, okay? Or divisible by 1. Negative 3x. So now I'm going to put my x there. Negative 3, I've got to have something for that negative. So what I'm going to do is I'm going to say negative 1 times 3. And then 3 is prime, so we stop there. We have 3 times a negative 1. And then we'll go to negative 18. So I'll say negative 1 times 18. And then I'll work on breaking down 18. So you can do 2 and 9, you can do 3 and 6, either works. So we'll just say 2 and 9. And then we'll break down 9 into 3 times 3. So those are our factors. So 2 times 3 times 3 times a negative 1. And we don't have any x's. So the first thing I'm going to do is look and see if all 4 boxes have the same number in common other than 1. Okay, we're looking for a GCF that is not 1 because there's always a GCF of 1. Okay, so I'm looking. They don't all have x's. They don't all have a 2. They don't all have a 3. So we really just have a GCF of 1, okay? So that means there's not something I can just take out of all the boxes that would change it. So what I'm going to do is I'm going to look at each row and each column, okay? So in this first row, I have 2 x's. And I have a 2 and a 1. So we'll put that here. So we get a 2x squared. Okay, I'm going to scribble it out so it doesn't get confusing. This next row, both have a 3 and a negative 1. Okay, so 3 times a negative 1 would give us a negative 3. So that is our first factor. I'll go ahead and put that answer down here. 2x squared minus 3. And then we're going the next direction. So they both have a 1, even though 1's negative. So we're not going to take out a negative 1 because they don't both have a negative 1. And we both have an x, so that we can take out. This way, they both have a 2. They also both have a 3. They have a 1 and a negative 1. They don't both have a negative 1. They don't both have an x's. So we just get 2 times 3, which is 6. So that's our next factor, x plus 6. And that is it. Last example for today. This is just similar to a question you're going to see on the quiz today. Okay, so all it is it gives you 2 different polynomials, and it wants to know which one is going to have the same factor, right? That's it, okay? So let's go ahead and break down the first one, and then we'll break down the second one, and we can kind of compare from there, okay? So 6x cubed, that means I'm going to have x times x times x to give me my x cubed. 6, we can break down into 2 times 3 times 1, okay? And then we'll do x squared. If you already know that 3 is a prime number, you know you should have 3 times 1 up there. 18x, and then we can break down 18. we can do 3 and 6, which would then be 2 and 3. So you have 2 times 3 times 3 times 1. And next, we don't have any x's here. So we're just gonna break down 9 into 3 times 3. Okay, then we're gonna look and see if there is a common factor for all 4 boxes. They don't all 4 have an x. Only these 2 have a 2. Oh, I forgot my times 1. They all have a 1, we already know that. But they actually all have a 3, okay? Notice all 4 boxes have a 3, which means this whole polynomial had a GCF of 3, okay? Meaning my answer for this is gonna have a 3 out front, okay? So what I'm gonna do is I'm essentially taking that 3 away. I'm factoring it out of the whole polynomial, and I'm gonna put it out front of my answer, okay? This is gonna be my answer. I still need to figure out these binomials though, okay? So my GCF for this top row, they don't both have a 2, they both have a 1, so we'll have a 1, and then they have 2 x's, so 1x squared. For this next row, they both have a 3 times 1, so a 3. Don't both have an x, so a positive 3. So that's one of my factors, x squared plus 3. And then we'll go column by column. They both have a 2 and a 1, so 2 times 1 is 2. And they both only have one x. And then this column, they both have a 1, and that's the only thing they have in common. So we're gonna put plus 1. So that's my other factor is 2x plus 1. And then we're gonna do this next box, okay? So these terms happen to be the same, so I know it's gonna break down the same, right? 2 times 3 times 1, and then x times x times x. Here I know I'm gonna have 2x is 1x. 3 is prime, so it's still just 3 times 1. We can break down our 8 though. All right, so your example on your quiz, they may not have the same first 2 numbers, that's fine, you would still need to break those down. So I'll break down 8 into 2 times 4, and then 4 is 2 times 2, okay? So we have 2 times 2 times 2 times 1, and then 4 just breaks down into 2 times 2. 2 times 2 times 1, okay? Now we wanna look and see if these 4 have a GCF like this one did. They all 4 have something in common. They don't all 4 have an x. They don't all 4 have a 2 or a 3. So your GCF is just 1. So in this case, we're just gonna get a binomial and a binomial, okay? So this top row, they all have 2 x's, or they both have 2 x's, so we get an x squared, and the only number they both have would be a 3 and a 1, so we get 3x squared. Bottom row, they both have 2 2's and a 1, right? So 2 times 2 times 1 is 4, and they don't both have an x. So we get 3x squared plus 4. Not the same, right? So let's look at our columns. They both have a 2 and a 1. 2 times 1 is 2. And they both have 1x. Looking promising to being our same factor. And then they both, the only thing they have in common is a 1. So we get the factor 2x plus 1, which means these are our these are our polynomials factored. The one that they both have in common would be your 2x plus 1. So that would be your answer. Okay, that is the factor that they have in common.